In this video, we're going to take a look at the multiplicative identity matrix in matrix multiplication. As with regular old multiplication, our multiplicative identity is the number 1, because when we multiply by the number 1, it does not change our multiplier at all. Okay, just like in addition, our additive identity is the number 0, because when we add the 0, it doesn't change the 3. Here, when we multiply by 1, it doesn't change the value of 3, and therefore we call that the identity. So in matrix multiplication, we also have an identity, a multiplicative identity and an additive identity. And we learned that the additive identity is the 0 matrix. Now we're going to take a look at the multiplicative identity. We signify the multiplicative identity by the letter I, and it's got to be capital with a subscript. Our multiplicative identity must be a square matrix, and you can see why, because our multiplicative identity has 1s along the diagonal. If our matrix wasn't square, we wouldn't have a balanced diagonal. We wouldn't go from corner to corner. So it has to be a square matrix for us to have a multiplicative identity for it. All other locations that's not on the diagonal are zeros. If we take a look at the identity matrix for a 3 by 3, again, it's all 1s along the diagonal from upper left to lower right, with all other elements 0. And the multiplicative identity for a 4 by 4 matrix is, again, 1s along the diagonal from upper left to lower right, and 0s in all other places. So let's see why we call this the identity matrix. If it's the identity matrix, when we multiply, it should not change the value of our matrix. Just like when we multiply by the number 1, it does not change the value of our multiplier. So let's create a test case here. And we are going to multiply, and we're going to use a 2 by 2 for simplistic sake. We are going to multiply the matrix 1, 2, 3, 4 by the 2 by 2 identity. And so in class, I've always used this method to multiply. I pull out my top column and I multiply these two numbers and these two numbers, and I add their product. And since I am multiplying the first row by the first column, I put it in the first row, first column slot. So I get a 1 plus 0. Then I go ahead, and since this column is already laid out, I multiply these and add them together. Since I'm using row 2, column 1, I'm going to put my answer in row 2, column 1. So 1 times 3 is 3, 0 times 4 is 0. Okay, the next thing I do is I'm going to pull out my second column, since I have no more rows to multiply. And I'm going to pull that column out and lay it on top, 0, 1. I'm going to multiply these and these. Now I'm using row 1, column 2. So when I multiply, I'm writing it in row 1, column 2. I get a 0 plus 2. And then I'm going to go ahead and multiply the bottom row by these numbers. I get a 0 plus 4. And when I go ahead and simplify, I get 1, 3, 2, 4. And you can see that my resulting matrix is the same as the matrix I started with. This matrix here is the same as this matrix. So when you multiply by the inverse matrix, the multiplicative identity, that's the matrix I meant, the multiplicative identity matrix, you can see that it doesn't change the matrix. Alright, so let's multiply, since matrix multiplication is not commutative. Let's go ahead and multiply it on the other side. We'll put our identity matrix on the left this time, and our other matrix on the right. And let's go ahead and multiply again. So I'm going to pull that first column out. I'm going to lay it on top so I know what I'm going to multiply. I'm going to multiply these two numbers. It's in row 1, column 1, so I get 1 plus 0. When I multiply the row below it, I get 0 plus 3. Now I'm going to erase that first column I had pulled out, and I'm going to pull out the second column instead and use that. Now I am working with row 1, column 2, so I get 2 plus 0. When I multiply that second row, I'm working with row 2, column 2, so I get 0 plus 4. And now when we simplify this matrix, I get 1, 3, 2, and 4, and you can see no matter which side of the matrix I put my identity matrix, when I multiply by it, it does not change my original matrix.